Okay, so example 3, solving a quadratic by complete the square. So what we have here is in this equation, we're looking to solve for x in the equation x squared plus 4x plus 1 equals 0. Okay, so once again, before we attempt solving the equation by complete the square, once again we need to check with ourselves here, is this equation here currently in the ordinary form, making it ready to solve using the complete the square. And what I see here is that I do have the square term with the leading coefficient 1, that is a good thing. My x term having coefficient b is a positive 4, which is everything is fine. The only thing that's keeping the equation here out of ordinary is that constant term 1 plus 1 here. So I need to bring this term, somehow I need to rearrange this term to the other side of the equation. And so the way to do that is to subtract 1 from both sides. And so here my ending equation is going to turn out to be x squared plus 4x equals negative 1. Now my current equation here is simply ready to use the complete the square methods here. So now, once again, in the methods for completing the square, you need the magic number. So the magic number for this problem is going to be, once again, b over 2, and my b in this problem is a 4. So now I have 4 over 2 positive, and that equals 2, positive 2. So now, what I need to do in the next step, the equal sign is here. On the right hand side, I'm going to add the square of the magic number to the right hand side. And on the left hand side, here's how magic happens. Produce for yourself a pair of parentheses, once again, with a square. Okay, and then here, there's always the x without any coefficient. Just the x with coefficient 1, no square whatsoever. And then the magic number we computed earlier, the magic number we calculated earlier. Now just simply put it here together with sign. So it's a 2 plus. So we have x plus 2 all squared equals negative 1 plus 2 squared. So now let's just go ahead and clean up the equation here in the sense that we go ahead and evaluate the right hand side. So negative 1 plus 2 squared, which is a 4, all equals 3. And then my left hand side is x plus 2 quantity squared. So now the equation of mine at this point here turns out to be an equation where I can just simply use the square root property to solve for it. And so now using the square root property, I can simply copy the x plus 2 expression and setting it equals to the square root of 3 with a plus and minus in front. And once again, at this point, keep in mind, square root of 3 is irreducible. You cannot go any further with square root of 3, so let's just leave it the same way it is. So now the last step here to solve for the equation here, we would like to solve for x anyway. So to solve for x, I need to subtract 2 from both sides. And here it turns out to be x equals negative 2 plus and minus square root of 3. And now the final expression here for the answer here, that's the final answer. It means, on one hand, x equals negative 2 plus square root of 3, and that's one solution. And the other solution here, logically, means x equals negative 2 minus square root of 3. So you have your choice of leaving your answer like in this form, or you can write out your two separate answers in these two forms right here. And that's how we solve for the equation x squared plus 4x plus 1 equals 0 in example number 3. Example 4 coming along, just another example of how we can solve a quadratic equation to get you more comfortable with solving a quadratic equation using the complete the square methods. So we would like to solve for x, and the equation this time appears to be x squared minus 5x plus 6 equals 0. Now, similar situation with example 3 that we had earlier. The equation that we have right now is out of ordinary. It's not already in the ordinary form yet. Now, I do agree that the leading term here has coefficient 1. That's a good thing. But then what makes the equation here out of ordinary is because of that constant term right here. There's the 6, the plus 6 right here. So I need to subtract 6 from both sides. and that gets me x squared minus 5x equals negative 6. And at this point here, I am completely ready for the complete the square methods. My magic number for this problem, the magic number that we need for this problem, once again, b over 2. Now, b in this problem, this is my b. I underline it right here. So that's going to be equals negative 5 over 2. And here, once again, we're in college algebra now, so I strongly recommend that you keep the fractions nature of these numbers here. I do not like to see, we no longer are using like negative 2.5 or something like that. Please keep the numbers in fractions. So in the most reduced fraction. So now my magic number here is negative 5 over 2, or just simply negative 5 halves, something like that, either way you want to write it. Right? So now, once again, what am I going to, once you've found your magic number, on the right hand side of the equation, of the current equation, which is a negative 6, now you are going to add with the square of the magic number. So negative 5 over 2 squared, you're going to add that to the right hand side. And the left hand side, at the same time, here's how magic happens. Once again, you just simply produce for yourself a pair of parentheses with a square as a superscript, and then always there's the x, leading coefficient 1. Leading coefficient 1, no square over here, and then the magic number, which is a negative 5 over 2, you just simply put it in here after the x, so negative 5 over 2. So now, cleaning up the right hand side by simply calculating what's going on the right hand side here. I have now negative 5 over 2 all square is going to be a 25 over 4, and then here we are adding to a minus 6. And the left hand side, for now, it remains the same. And so, once again, if you're at this point, you are once again required to know some basic operation with fractions. So if you're not having that skill going, if you're not having that skill nailed down, make sure you check out my other videos on how to add and subtract fractions, as well as adding a singular number with the fractions. But here, according to the calculations, negative 6 plus 25 over 4 is going to be, now my common denominator is a 4, so it's going to be a positive 1 over 4. So that's how that's how I add negative 6 with 25 over 4. The left hand side remains x minus 5 half, all squared. So now, this final equation of mine, once again, I am in the form, making it ready to use the square root property to solve my equation here. So, the square root property is saying I can just simply copy down the expressions on the left hand side without the square, so now which is x minus 5 over 2, and setting it equals to the square root of 1/4, and with a plus and minus. And once again, if you're not sure how to find square root of 1 over 4, make sure you review your square root skill, but square root of 1/4 is a 1/2. So your answer here is a plus and minus 1/2 on the right hand side after square root. And here x minus on the left hand side, x minus 5 over 2. So now one last step to solve for this equation, correct? Adding 5 halves to both sides. And that is going to give me, that is going to yield for me x equals 5 over 2 plus and minus 1/2. Now, in this problem specifically, I am going to move further into finding the actual two final answers for that. So on one hand, x equals 5 over 2 plus 1/2, and on the other hand, it means x equals 5 over 2 minus 1/2. And so once again, if you're not having your fraction skills ready, make sure you review your fraction skill. But here 5 half plus 1/2, that gives me 6 over half, 6 half, that equals 3 after reduction. So once again, 5 half plus 1/2 equals 3. And the other answer of mine, x equals now 5 half minus 1/2, that gives me 4 half, which is 2. So my final two answers are x equals 3 and x equals 2. And that is how we solve the equation using complete the square.